I had a couple of messages from Paul Henningsen at LMC. They're now open again in Tempe. And he happens to have his Maggie 0.7s and 1.7s hooked up. So anyone who wants to hear them can go down and do that. And I told him I would pass that along. So moving forward with Roger, and Roger's background, for those of you who may not be aware, Roger's been at this for 40 years. He published his first article on electrostatic speakers in 1974, followed by another one on amplifiers to drive ESLs in 1976. His contribution to audio includes the invention of the curved freestanding electrostatic loudspeaker driver and the development of the extremely compact line woofer systems, integration of electrostatic speakers and transmission line woofer systems. Recognitions include the 2010 and 2016 Absolute Sound Golden Ear Awards for the Model 10 speaker system. Dagogos, I never could say that name. September 13, Lawrence Borden wrote that his review, his only regret is not having purchased them years ago, and that the Sanders Sound Model 10s are amongst the finest speakers I've ever heard, and certainly the best I've owned. That's a pretty good statement. The backstory is interesting. In '74, Roger authored an article in Speaker Builder magazine about electrostatic speakers. In '76, that was followed by an article on amplifiers to drive them. In '80, he wrote about the construction of an electrostatic speaker with a curved diaphragm, and he was the first to develop this curved profile. You might remember that in 2004, Roger Sanders left Intersound, and in 2007, he formed Sanders Sound Systems, now located in Conifer, Colorado, which is just outside of Denver. It's important to note that Mr. Sanders has managed to continue to make and improve his ESL amplifiers as he has resumed production of his innovative electrostatic loudspeakers. With the new Sanders sound system, the Model 10 loudspeakers, he abandoned the curved electrostatic panels that he had developed, explaining that the curved surface introduces a new set of problems not inherent with the flat panels. So with that, Roger, and I hope I got most of that right. I've plucked it out of the internet. Anything that needs correcting?
No, that's very generous of you. Everything's accurate there.
Oh, wow. I've never been, might not ever hear those words out of your mouth again. Okay. I have a few questions I've highlighted here for you and a couple from some of the participants. Let's start with a simple one. Like, what do you think is audio's biggest achievement in the past 40 years, or as long as you've followed it?
Oh, man, that's so easy. That's not even a fair question.
Okay.
We actually have to take it back beyond 40 years, though, because there hasn't been another huge invention that was required to make what I'm going to say was the best invention in the last 40 years. So we need to go back 70 years.
70, okay.
Yeah. And 70 years, huge, huge invention, changed the world, especially in audio, and that is the invention of the transistor.
Okay.
Semiconductors were absolutely essential to get the kind of performance we have today, and led directly to the biggest invention in audio in the last 40 years, which without any question has to be digital recording.
Okay.
Digital was invented specifically to address the insoluble problems and flaws in analog recording, and it's been a total revolution in the quality of sound we could get. I mean, I remember back in the 50s and 60s when I started in all this, all we had was LPs and open reel tape, and the sound quality was never realistic. When I got into my own recording, both at University Recording Studio, my own recording studio, and on-location mastering throughout the 60s and 70s, it was just a constant frustration. You could never make a recording that sounded like the live microphone feed. you always heard all kinds of flaws, particularly noise, distortion, frequency response errors, wow and flutter, and unstable or just unstable sound both in amplitude and frequency when you try to place things back. And so the no recording, even on a studio mastering machine, sounded like a live microphone feed. But when digital came out in the early 80s, we finally could make a recording that you could not detect any difference between the live microphone feed and the recording of that feed. Truly a revolutionary and dramatic step upward in the quality of sound we could get, quality of sound reproduction. It was so good, in fact, those of you who've been around long enough, may remember the huge hue and cry from the record companies who hated the idea of digital recording because you could now make serial copies of the recordings over and over and over as much as you wanted, and they were just as good as the master tape. And they never deteriorated like analog did. Every time you made an analog recording, you added noise, added distortion, added wow and flutter, and got it to the point where it was unlistenable after a couple of copies. So piracy was not much of a problem back then in the analog days because you couldn't make a realistic analog recording. But when we got digital recordings, you could make them and they sounded perfect. And they finally, all kinds of lawsuits took place. I don't know if you guys remember all of this stuff, but they finally came up with what was called SCUMS. That's a serial copy management system. And they required the digital tape recorders at the time to have, for consumer use, that they had to have SCUMS in there. And SCUMS would allow only one copy. You couldn't make multiple copies in the digital format because you could make pirated copies and sell them, and they sounded just as good as the originals. I mean, that's just how good digital is and was and still is. And clearly, that's the biggest revolution in sound in the last 40 years. But transistors had to be present for that to happen.
Exactly. Well, that's a very detailed answer. Thank you. Let me go on from there to the next question that I have. What do you see as the biggest need that exists for improvement in the hi-fi world today?
That's another really easy one.
Okay.
You're not going to like it. But the truth is that the world of audio, or high-end audio, or audiophile kingdom, whatever you want to call it, lives in a fantasy world where audiophiles are totally gullible. They'll believe anything they're told by anybody. They don't demand proof of anything. All the snake oil salesmen out there are just telling them lies to sell their products. Nobody demands or gets any proof that such and such a component actually sounds better. They just claim it does. And it's just a total disaster for the innocent audiophile who's just trying to get good sound, because there's no agreement, because there are no facts. It's all just opinion, and no valid testing is done. Used to be at least people did objective measurements, which we can do much better today than we could back then, especially with the invention of digital and spectrum analyzers. So you can really tell exactly what's going on with equipment today in tremendous detail with far more resolution than any human can hear. But nobody's doing that anymore. And so audiophiles really are just shooting in the dark. They don't know what they're getting. They don't know whom to believe. There's all this conflicting opinion. None of it's true. Everything you hear in the audiophile world today is a lie. And it's easy to prove with valid testing. The problem is nobody's doing valid testing. The magazines should be, but they're beholden to the advertisers. And they don't want to offend anybody, and they don't want to put any information out there that's really honest. And they've gotten to the point where they've managed to convince audiophiles not to believe measurements. So measurements are far more accurate today than they ever were before. And when measurements don't seem to coincide with what you hear, there's good scientific reasons for that, and you can correct for that, but you have to do valid scientific work towards this. And this is a huge topic that I'd love to spend several hours discussing with you guys, but obviously we're time limited here. But so the biggest problem in audio is that people don't get good quality sound at a reasonable price because they're lied to, and everybody's just trying to make money. Let me use it, though, a couple of very blatant examples of what I mean. I think you'd probably agree today that most audiophiles have come to believe that you need to have clean mains, that you need to use a power conditioner to get good sound. This is a complete and total hoax. There's nothing about distorted mains that will degrade your sound quality. In fact, you can prove very easily that it will improve sound in some ways. Because, let me be a little more specific, a little more technical here, even though it'll take a little time. The sound, the mains frequency, 60 hertz in this country, ideally should be very pure and not have any distortion on it. Now, what is distortion? Distortion are simply frequencies that shouldn't be there. In the case of the mains, it should be 60 hertz, that's it, a sine wave, nothing else. Any harmonics of that or noise are simply higher frequencies that don't belong on the mains. But the question is, do those frequencies that produce a, quote, dirty mains, if you want to believe the sellers of power conditioners, does that degrade the sound? And if so, how? Well, I can tell you right now, it doesn't degrade the sound because the power supply that you have in every component will automatically take care of it. Specifically, if we look at how a standard linear power supply works, you've got three parts. One is a power transformer that converts to a different voltage that you're going to need. Number two is going to be a bank of rectifiers, typically in a bridge rectifier format, to convert that alternating current from the transformer into DC, direct current, which is what's required to run electronics. However, the power coming from the transformer is not pure DC. It's pulsating DC after it goes through the rectifiers. And this pulsating DC means you have DC pulses that go from 0 volts to the maximum voltage of the transformer, whatever that happens to be. Typically in an amplifier, it's 100 or more volts. And so you get these pulses. In this case, you get 120 pulses per second after you rectify it. And this would be incredibly noisy if you just fed it to the amplifier. You'd hear nothing but massive hum. Now, obviously, that's not what you hear. Why? Because you have filter capacitors, a bank of capacitors that store the pulses of electrons coming from the power supply. And then it's kind of, the capacitors are kind of like a bucket of water. If you want a smooth flow of water coming out of the bucket, let's say you have a valve on the bottom of the bucket, and you fill the bucket with water, and you open the valve, you will get a smooth flow of water out of that bucket. Now, you can keep the bucket full by using pulses of water from your garden hose. And even though you put pulses of water in, you're going to get a smooth flow of water out. That's exactly what the power supply capacitors do. They take the pulsating stream of electrons coming from the transformer and rectifiers, and they feed it into the capacitors where it's stored and smoothly is released into your amplifier. So the filter capacitors are called filter capacitors because they filter out this noise. Now, let's assume that you had extra frequencies on the mains. In other words, a dirty mains with distortion on it. What would happen? Well, one thing I haven't mentioned to begin with is that a power transformer only operates at low frequencies. You need a very expensive and very specially designed transformer to pass high frequencies. So since the main is only 60 hertz, you don't need a high quality transformer to pass the signal. All you need are, it'll only pass 60 hertz and a little bit higher, but as soon as you start getting much above 60 hertz, it's going to roll off the frequencies and will not pass those higher frequencies. In other words, if you have, say, radio frequency noise on your mains, it's not going to get through the power transformer. The power transformer is inefficient at those higher frequencies, and it's going to convert that energy into heat as eddy current losses in the transformer's core. So none of those frequencies are going to get through. You're still basically only going to have the fundamental 60 hertz frequency. And I might point out this characteristic of power transformers is often used by power conditioner sellers who simply take a big power transformer of what they call an isolation transformer. That is, it has the same voltage in as it does the voltage out, so it doesn't change anything. It just drives a signal through the transformer, which is going to roll off high frequencies and therefore eliminate any noise that's on the signal, on the mains. But the power supply, the transformer in your power supply already does that. So why bother with another transformer out there and pay thousands of dollars for it? That's thievery. You're being ripped off. So let's get back to the mains here. Let's say we got a signal coming through from the mains that's dirty. And let's say, just for purposes of this discussion, that this signal managed to get through the transformer, even though the transformer normally rolls off the high frequencies. But let's say it's not that a higher frequency, and a lot of it gets through. Okay, now that signal, that noise signal frequencies are going to be rectified by the rectifiers and passed out of the filter capacitors, where they'll be stored just like the extremely noisy signal that's normally coming from the mains. That is the mains fundamental frequency. The noise frequencies, of course, are going to be much, much smaller than the mains frequency, but nevertheless, if they got through the transformer, they would be pulses of DC. They would go into the capacitors, where they would be filtered as far as noise is concerned. You're not going to hear them. And they're going to add energy to the power supply, which means if you're driving a power amplifier with that power supply, you're going to improve the power available from that amplifier. So in that regard, noise frequencies could actually improve the performance of your amplifier by giving it more power. And there's nothing about these noise frequencies that would degrade the performance of the amplifier in any way. However, there is something about power conditioners that can degrade the performance of your amplifier, and that is all power conditioners insert series resistance between your mains and your power amplifier. And if you're using a high power amplifier, this is going to reduce the power that's available to the amplifier, and therefore reduce its power output capabilities, and can, in certain circumstances, cause it to clip, that is to run out of power, at a lower power level than it's supposed to. So on my very powerful amplifiers, I advise customers, do not plug them into a power conditioner. Plug them straight into the mains receptacle so you can get the maximum power available. Okay, so that's just one example of a complete lie and a hoax in the audio industry. And we could go through dozens of examples if we had the time. But I'll stop here because I know you have more questions, and I don't want to just rant about, the lies that you hear in the audiophile world.
That's okay. I do have one question that comes to mind. People who build amplifiers like Dan D'Agostino, for example, when we were in his factory last year, he had a German-made, I think it was a $40,000 or $50,000 DC converter, I suppose it was. Maybe you're familiar with what I'm talking about.
Not sure.
Oh, I wish I could recall the name, brand.
They were battery packs, Jeff.
What, pardon?
They were battery packs.
Battery, oh, is that what they were? Battery.
Yeah, so what he was, first off, Dan said basically, don't worry about power conditioning with his amplifiers because the amplifier is already built to clean everything up. So much like what Roger is saying here. But then he did have in the shop, Roger, which I was baffled as well, basically like these mini refrigerator size battery packs that you could use to run an amplifier off of.
Sure you could. The battery packs are power, let's put it this way. The capacitors in a power supply are basically rechargeable batteries. They're very, very fast acting compared to a normal rechargeable battery. But a capacitor is fundamentally a battery. Now, one of the advantages of using a battery is that it's pure DC. There is no mains frequencies involved. There's no pulsations of DC going into power supply capacitors. So from a theoretical standpoint, a battery will give you the most pure power supply you could possibly have. So if you want to use a battery to drive your equipment, you're welcome to do so. It'll do a great job. However, from a practical standpoint, that's not very practical because you got to keep recharging it and so on. And the fact of the matter is, what are you what are you solving? What problem are you solving with the batteries? Well, there's only one problem you could be solving, and that would be hum. If the power supply is putting out not pure DC, but pulsating DC at least a little bit, then there will be some hum, and you could hear that in your speakers if it was not well designed. But of course, today we all use very large capacitor banks, and you don't hear any hum coming out of any modern amplifier. You go right up to the speaker, stick your ear in it with the amplifier on, and you will not hear any hum. Now, when you do that test, though, you got to be sure you disconnect or at least turn off all the upstream components from the amplifier so that you're not reading any hum from them. You just want to compare your amplifiers. So you have to just test that one device. But do that. Turn off your preamp and then leave your amplifier on alone, and go up and put your ear right up to the woofer and see if you hear any hum. I'll bet you don't. So if you don't hear any hum, then there's really nothing to be gained. You don't have a problem that you need to solve with a bunch of expensive batteries. But if you want to run a great big battery pack, be my guest. That'll work.
Okay, well, that's a good explanation. It makes sense. I could follow that. Let me take you to a slightly different direction here, Roger. When you built a new product to be included in your line, did you make all the voicing decisions, or was it done more or less by committee?
You have to understand, I am not an audiophile. I'm a scientist and an engineer. The purpose of an amplifier is not to be voiced to have a certain sound. The purpose of an amplifier is to pass the original signal without any alteration at all, with the exception of adding power to it. So when I build an amplifier, I build it so that it does not have any sound of its own. There is no voicing. You put it on a spectrum analyzer. You minimize the distortion to, in the case of my amplifiers, usually around 1,000th of 1%. You have linear frequency response. You have no noise. And that produces an amplifier that sounds perfectly transparent and effortless. It does not have a sound of its own. Now, this gets back to, though, the audiophile world and all the BS you hear in it. The problem with most amplifiers today is that they do have a sound of their own because they are not operated within their design parameters. And I say that because most amplifiers are grossly underpowered and are constantly clipping the musical peaks while you're playing music loudly. And therefore, they're misbehaving dramatically. They have tons of distortion, nonlinear frequency response. They sound strained. They're compressing their dynamic range. And because amplifiers, when they're clipping and breaking up the way they are, they do so differently depending on their circuit design. So they do, in fact, sound differently. The solution to this problem, though, is to have enough power that you don't clip your amplifier. And when you do that, you'll discover that a modern amplifier that meets the basic criteria for good sound, which is not magic. The basic criteria for good sound is linear frequency response, inaudible noise, and inaudible distortion. Inaudible noise means a signal to noise ratio at least 90 dB, distortion less than 1%. Surprisingly, humans can't hear very well. Humans can't hear less than 1% distortion, which is one of the reasons that tube amplifiers are tolerable, because they usually have more than 1% distortion. But good solid state amps have like 1,000th of a percent distortion, but most humans can't hear any difference between them and a tube amp operated within their design parameters, remember, because you can't hear the difference between 1% or 1,000th of a percent distortion. But it's very easy to measure with a spectrum analyzer. Not only can we measure the total distortion, we can measure the contribution of every harmonic frequency that's causing that distortion. Spectrum analyzers are amazing tools. So the reason the amplifiers sound different is because they're clipping. If you get an amplifier with enough power, it doesn't clip. How much power do you need? Well, with a typical speaker that's about 90 dB sensitive, I'm talking about the usual cone and dome type speakers with direct radiation, not horn speakers, which are much more sensitive. But you need at least 500 watts per channel. And that's not my opinion. That's easy to prove. You just put a meter or a scope on your speakers and start turning up the volume until you see clipping on the scope. That's very easy to do. And you'll find very quickly that to have clean musical peaks on dynamic material, listen to at the live levels that most audiophiles enjoy, at least 500 watts is required. That's why I don't make amplifiers of less power than that. In fact, my amplifiers will do typically about 1,000 watts per channel in the typical 4-ohm speaker. And even that's not enough for like magnepans, which are much less sensitive than Conan Dome speakers. So if you're not using at least a 500 watt amp, you're guaranteed to have poor performance. And frankly, I don't understand why anybody makes amplifiers of less than 500 watts, because that's the minimum required. And I have customers often asking me, well, if you read on the internet, my amps, especially my Magtech, which is the only high power amp in the world with a regulated power supply, all others use free floating power supplies, which have lots of problems. But I have excellent reviews on my amplifier simply because it isn't magic, and I don't claim to be a genius. I just measure what it takes and see that it takes 500 watts. So I make an amplifier that doesn't clip, and at least on most speakers. And therefore it sounds really good. And I have people ask me to make lower power, cheaper ones, and I say, I refuse. I am not in this business to make stuff that sounds bad. The minimum required for an amplifier is 500 watts. If you're not using that, you're guaranteed poor performance. And the idea that you hear like in the audiophile world is that, oh, low powered amplifiers sound better than high power ones. It's utter, complete fantasy world. It's just not true. And again, don't take my word for it. Put a scope on your speakers and watch what happens. It's really easy to do.
I watched your scope in your factory there, and it was surprising. Even with your high-powered amps, they didn't have to get super loud before it started approaching clipping.
That's right.
So I don't know where you'd be on a lower powered, wouldn't work.
Well,
Paul looks like he has a question.
Because I'm like super baffled by this, because so I have like a small room in the back of my house that's a listening room, and I have a 100 watt amplifier at 8 ohms, and I'm thinking to myself, if I'm only 2 meters from my speakers and the volume of the room is, I mean, if you think about like a 10 by 11 by 8 room, I mean, if I'm only listening at like 85 dB, based on the calculations I have, I won't need all 100 watts.
You are correct, but your condition is not typical. Normally, okay, let's keep a couple things in mind when it comes to how much power you need for loudness. To begin with, there's the square distance factor. If you double the distance from your speaker, your listening distance, it doesn't require twice as much power. It's a squared factor. You need 4 times as much power if you move twice as far from your speaker. So the difference between listening at 1 meter and 2 meters isn't the difference between 50 watts and 100 watts. It's the difference between 50 watts and 200 watts. It's a lot more power. So this distance squared factor has to be considered. Secondly, the size of the room matters. Obviously, the room contains the air that you're having to vibrate, and the bigger the room, the more power it's going to take to energize all that air. Thirdly, the type of music you listen to matters. Well, I won't say obviously, because it isn't obvious to a lot of people, but highly dynamic music, like say a full symphony orchestra, or pop music for that matter, it's usually very dynamic, lots of percussion and so on. These are highly dynamic. The average music level is about 1/10 the peaks. In other words, you need about 10 times more power to reproduce the peaks than you do the average level. On the other hand, there's music that's not very dynamic. Take, say, string quartet, very low dynamics. So, if you listen to pop music or classical, you're going to need a lot more power than you will if you're listening to a string quartet or classical guitar or something like that. So your situation's unique. You're listening at a lower level, only 85 dB. Most audiophiles listen to 100 to 106 dB is typical. In a typical size room, it's probably 12 by 18 feet or so. And they're sitting back well away from the speakers, typically 3 or 4 meters. So in that case, you need a lot more power than you do. So in your specific case, you're probably all right with 100 watts. Although if I were you, I'd put a scope on it and check. But in your case, you're a special situation.
He is a special case, you're right. Hey, Roger, what I meant to ask you with that question, I'm sorry I wasn't clear, was not so much about your amplifiers, but with your speakers and voicing your speakers. Is there a different answer for that, or is it the same answer?
It's a different answer for that. I do
Okay.
not voice my speakers, and we don't have a committee involved. We use instruments. And of course, our speakers come with a room correction system, and they've been fully and very carefully equalized in a laboratory for linear frequency response. Now, most speakers do not have linear frequency response, largely because most audiophile speakers are still not using loudspeaker management systems that allow them to be properly equalized, so they're already heavily compromised. And you don't get linear sound from most speakers today. With my speakers, when you get them at home, you do get linear sound. And then, so that's your reference standard is linear sound, because all the recordings are made, they're made so that they can be played back to a standard. That standard is linear frequency response. Now, that doesn't mean that you as an individual like linear frequency response. You may prefer nonlinear response. In fact, I would say most of us do prefer somewhat, shall we say, altered frequency response. And I say that because virtually all of us prefer bass that's a little heavier and a little more impactful than what you get with true linearity. But in my speakers, what I do is I give the customer complete freedom to make my speakers sound, or voice if you want to say. You can voice my speakers yourself to whatever you like to hear. And that's because the loudspeaker management system that comes with my speakers includes a virtually unlimited amount of parametric equalizers, which give you tremendously precise control of the equalization. They also have, if you prefer the more older and less, I'd say somewhat obsolete graphic equalizer, that's available. And of course, the room correction system, you can put in curves that the room correction system will match automatically to what you prefer. For example, because most people prefer somewhat slightly heavier bass than linear, I recommend in my instructions when you get the speakers that you select as a recommended target curve the slightly boosted bass curve. And it's simply listed on there as a recommended curve. You also have a linear curve. You also have a highly reverberant curve. You can pick these different target curves to get the speakers to sound the way you like. But like I said, because most of us prefer a little heavier bass, I suggest that you try the recommended curve. Let the loudspeaker management system then measure the speakers in your room. And here's a very, very important point. It almost doesn't matter what the manufacturer voices his speakers to sound like, assuming he does so. Because when you put a speaker in a room, it's going to interact with the room and completely change its frequency response. It's not going to be what the manufacturer intended or what he developed in an anechoic chamber, assuming he even went to the trouble to do so. So a perfect speaker is still not going to sound perfect in your room. You have to deal with the interaction between the room and your speakers. And currently the only really practical way to do that well is with a loudspeaker a room correction system. The only other way to do it is the way we used to do it, which doesn't work very well. And then is try positioning your speakers at different places in the room because they interact with the room differently depending on the dimensions between walls and corners and where the speakers are located and how far apart they are and all kinds of other factors. What kind of damping you have in the room, what do they call it? Room treatments, that's what they call it, treatments. All this changes the frequency response of the speaker, and therefore it's kind of hopeless to even try to voice the speaker as a manufacturer because it's going to sound different when it gets in a room. But the room correction system will fix that. My speakers will sound the same in every room you put them in if you run the room correction system properly.
So for example, when you set up your speakers in the room they're in now in your home, how long did it take you messing around with the equalizer to get it where you wanted it, where you felt they were optimized?
The room correction system is fully automatic. And once you answer a couple of questions in response to it, it's going to ask you some things to get what you want, such as what is the recommended curve you want to use? And it allows you to pick. And anyway, you might spend a minute answering the questions, and then it actually runs its measurements in a matter of about 2 seconds for each speaker.
Aren't you using the microphone system
Yes.
you had?
Yes.
Okay. Well, you're a lot quicker with it than I was.
It doesn't take long. You know, the actual test tones, which run through, they take about 2 seconds to run the whole frequency range, and it's done. That's the test, and then once it has that information, it takes the computer, depending on how complicated the room is, but the computer will then usually take maybe 30 seconds to do its computations and develop a mirror image equalization curve that it then applies to the signal to correct for the room. So that's 30 seconds. And then finally, because my speakers I use controlled dispersion, and therefore the typical room correction system, which is designed for wide dispersion speakers, does not work correctly with my electrostatic panels. So I have you go back and manually remove any room corrections that the room correction system installed above 1 kilohertz, because my speakers work on what's called precedence effect. They don't have any interaction with the room above 1,000 hertz. So you must not use any room correction above that. So it may take you a few minutes to remove the corrections above 1 kilohertz. But when I go to set up a system, like when we go to show, it typically takes us less than 5 minutes to run the room correction system. And we're done.
Okay. Well,
but of course, I'm familiar with it. It's quick.
Yeah. Well, now, I don't know, I didn't mention this to everybody when we first signed on, but those of you who aren't familiar, Sanders Sound currently produces one product. It's the speaker, the electrostatic speaker with a transmission line base 12-inch speaker. And with that purchase, you get the room correction system, or what would you refer to that as?
Well, we call it a loudspeaker management system because it does much more than just room correction.
Okay.
The loudspeaker, and I need to correct you, the woofer size is 10-inch.
Oh,
and
10
inch.
inch.
And it's not the only product we make. We make what I could, the world's most unique high power amplifier, the Magtech amplifier. We also make speaker cables, interconnects, and we also make our own preamp. So we have several products that we make. But the speaker system is my bread and butter. That's what I'm known for. And that comes complete with one of our Magtech amplifiers and the loudspeaker management system plus both speakers. Now, the loudspeaker management system is a fundamentally key element that is essential for good performance from all speakers. Every speaker needs it because it does several things. First of all, it does the crossover functions. Now, passive crossovers have very poor performance, and you can't get steep enough crossover slopes, and you tend to have high distortion, have hysteresis losses, which puts all kinds of time delay into the signal. Passive crossovers are just unsatisfactory. They're obsolete, and I don't understand why anybody uses them anymore. With the loudspeaker management system, this is a digital device which gives you extremely precise control of the crossovers and of great importance, very, very steep crossover slopes. We use 48 dB per octave slopes. Most passive crossovers are only 12 dB per octave. This is simply not satisfactory for a whole bunch of reasons, which I don't know if we have time to get into that. Let me continue though with the other features of the room corrections of this loudspeaker management system. So we have much better crossover performance, number one. Number two, we have complete equalization control of each individual driver in the speaker. And all this control is available in real time while you're listening to music. You can actually change the performance of the speaker infinitely, both in equalization, in time management, in phasing, in crossovers, in crossover slopes, time delay, time alignment. All these things can be done in real time while you're actually listening to music with these loudspeaker management systems, which makes it amazingly effective when you want to voice the speaker the way you want it. Let's say you don't like the sound exactly the way it's coming out of the speaker. Maybe you want it to be a little brighter, let's say. Well, you can go in and pick I would recommend a parametric equalizer because it gives you the best control. You can set a parametric equalizer and adjust its frequency and gain and bandwidth and all this stuff right in real time while you're listening to get exactly the amount of brightness that you want.
So are you saying, just so I understand this, could someone buy a parametric equalizer, for example, who doesn't have who has a normal set of speakers with a crossover, et cetera, and add that to their system to correct the room?
Yes, sure.
Okay.
Okay, the next item that's very, very important is the time alignment system. Most audiophiles don't really understand time alignment, so let me go ahead and explain it in a layman's manner that makes it perfectly clear finally as to what this is about. You have more than one driver in a good speaker. Let's say you have a two-way speaker with a woofer and a treble driver. Okay, now, I'm going to use an extreme example to make the point here. You want the sound from both those drivers to reach your ears at the same time. Now, let's say that you took that treble driver and you left it in your normal listening room position. Let's say it's 6 feet from you where you have your speakers now, but you took the woofer and you put it a mile away. Now, remember, we got a crossover here and we're sharing frequencies. The bass, the woofer is reproducing a lot of the mid-range because it doesn't roll off instantly, and it's, take my word for it, woofers reproduce the mid-range, which is one of the really bad things about passive crossovers. And so is your treble driver reproducing the mid-range. So you have two drivers reproducing the same sound. Not only are these drivers different, which is going to screw up the critical mid-range to some degree, but now if the woofer's a mile away, the sound from that woofer is going to take about 4 seconds to reach your ear, where the sound from the treble driver is going to reach your ear almost instantly because it's only 6 feet away. Now, I think you can imagine quite easily that the sound of the mid-range, where both drivers are reproducing the same frequency, is going to be really weird because some of it's being reproduced immediately and some of it's coming in 4 seconds later. Not to mention that just the bass is going to be 4 seconds behind the rest of the music that's coming out of the high frequency driver. So that is a time alignment problem, meaning that the sound from both drivers from that speaker are not reaching your ear at the same time. And our ears are extremely sensitive to this. So it's very, very important to fix this problem. And on some of the really expensive speakers, they try to align the drivers mechanically so that they are in the same plane as far as their radiation point is concerned, which means that you cannot mount, say, a dome tweeter on the same panel that a woofer is mounted on, because the woofer is a cone and it's radiating from deep within its cone, say maybe 6 inches behind the front panel or the front baffle, what it's mounted on, whereas the dome tweeter is about 1 inch in front of the panel. So you've got a 7-inch error in time alignment between those two drivers. And that's going to be very, very noticeable to us when we're listening to mid-range frequencies, especially where those two drivers are reproducing the same frequencies. So to solve that problem mechanically, you've seen big expensive speakers like Focals and Wilsons, and they have boxes stacked on top of boxes. Each driver has its own box. And those boxes are not in a straight line. They're staggered behind each other in order to get their voice coils roughly aligned. And that's ugly as hell, if you don't mind me saying so. But it works. It works. It does make the speaker sound better because all the sounds are arriving at your ears pretty much at the same time. However, it's cosmetically a real nightmare. And a much better way to deal with this problem is electronically. And the time alignment system in a digital loudspeaker management system will introduce, or let you introduce, time delay in the early arriving drivers as needed in order to get them time aligned with the later arriving drivers. For example, at my speakers, I delay the sound that comes out of my electrostatic panels by 0.29 milliseconds so that it's aligned perfectly with my woofer. And that's one of the reasons I'm able to get perfect integration between the two drivers. There are other factors involved with the integration too, but you've got to have the time alignment exactly right, or it's doesn't sound like a single unified speaker. So this whole issue with the room correction, the loudspeaker management system, I think you can see every speaker system needs one. But to the best of my knowledge, I'm still the only high-end audio manufacturer who provides speakers with a loudspeaker management system. Although I will point out that in the professional field, virtually all their speakers use loudspeaker management systems. In fact, that's where I get my management system, from the DBX Pro division that sells professional equipment for auditoriums and so on, because they want their stuff to sound as good as they can get it. And they time align everything, and they use loudspeaker management systems everywhere. You don't see passive speakers, passive crossovers used in the professional world anymore.
Right. Okay. Well, let me give you another, what you might find to be an easy one. Who in this industry do you admire the most, living or not?
I would say I would go back to the pioneers. I would have to doff my hat to Peter Walker, who basically invented the home electrostatic loudspeaker in 1957.
What was his? And
He has, it's certainly not a perfect speaker, but for the day, if some of you are older and lived through the 60s and even the 50s, knew how bad loudspeakers sounded back then, especially when they're driven with 15-watt amplifiers that are constantly clipping. When we got the Quad 57, it was truly, truly a revolution in sound, because for the first time you had incredible clarity, which of course is typical of electrostatic speakers because they're massless compared to the cones and domes, which have a lot of mass and really can't follow the audio signal accurately. Furthermore, the electrostatic speaker is the only speaker whose diaphragm is driven uniformly over its whole surface, so that it does not have any breakup modes like cones and domes do. As a result, it's distortionless even at high frequencies. And so when Quad came out with the Quad 57 and you had a massless speaker that could actually follow the waveform accurately, combined with no distortion, it was astonishing when you'd hear that. And in fact, I remember my first experience hearing the Quad. I said at that point, that's my future, that's my life. I was in college at the time, and that changed my life. That's what put me on the path to developing what I consider today's finest electrostatic loudspeakers, or loudspeakers. And I've spent my last 45 years now developing that. And it was Quad that sent me in that direction. So I doff my hat to Peter Walker, even though his speaker had many serious faults. Like it wouldn't play loudly, it wouldn't play dynamically, it didn't have any bass. But as a incredibly clear, detailed sound, nothing came even close in that day and age. Since then, I will say that cones and domes have improved dramatically, but they still are no match for an electrostatic speaker. They're inherently too heavy, too massive, and do not have good control of their cones. They break up and have a lot of distortion, and you cannot get the kind of detail and clarity that you get from electrostat out of dynamic speakers.
okay, well, that's a good one. I agree with you there. And so what would you say the accomplishment that you're most proud of in the audio industry?
Let me answer a question. There was a comment on the screen here just a moment
Oh,
ago
I'm sorry, go ahead.
about magnepans. By the way, I haven't been responding to the comments on the screen much because frankly, I don't have time to read them much, but I caught that one.
Good.
Understand that magnepans are not electrostatic speakers. They're magnetic speakers. They use a diaphragm, flat diaphragm like an electrostatic, but they're not driven by a massless electrostatic force. They have heavy wires and conductors on their diaphragms, and they also have to use fairly thick, heavy diaphragms to withstand their high heat and to support these heavy wires. There's a lot of moving mass in a magnepan speaker. Also, it doesn't drive its diaphragm uniformly over its whole surface. The wires, or some of them like Eminent Technology uses actually a printed circuit board type of conductors on the diaphragm, but it's the same thing. There's conductors that are made of heavy metals on the diaphragm, and these are spaced typically an inch or so apart, maybe a little closer, but they're not uniform everywhere on the diaphragm. So the diaphragm does not follow the voice coil exactly, although I will say I think magnepans, or planar magnetic speakers is the type of speakers these are generally considerably better than cones and domes, because they do have less distortion. They do have a bigger image field because they're using a large planar panel. Actually, they use crossovers in multiple panels, so that's not quite like an electrostat that doesn't use any of those things. But the bottom line is they simply are too heavy to reproduce the detail you get with an electrostat. Also, when you get into massive speakers, you run into this problem of what we call bloom. You probably have noticed that if you listen to typical magnetic speakers at very low levels, they just don't sound very clear and dynamic. And that's because you have to drive them hard enough to start to produce the dynamic range that's required from a massive object. And they just are sluggish. They just don't respond quickly to tiny signals. So they don't sound very good at low levels, which is one of the reasons we like to listen to our music loudly. But that's not true of an electrostat. With an electrostat, you get all the detail even at the quietest levels because it's driven uniformly everywhere on its surface without any distortion and with no mass to interfere with its motion. It simply transfers its energy directly into the air without any mass of any significance within its own inherent design. But anyway, Maggies are very good. I think they're a lot better than most speakers. And also you ask who I appreciate. I think Winey at Magnapan is a brilliant engineer. I think he makes a great product. He treats his customers very well, and I'm very concerned about treating customers well. Anybody who's dealt with my company knows that I'm serious about that, and we do take the best care of our customers. But so does Winey, and also his products are reasonably priced. He's not ripping people off, charging $100 grand for an amplifier or $250,000 for a speaker system. His speakers are reasonably priced. He's giving you a lot of value for a fair price, and he treats his customers well. So I would give him very high marks.
I forgot, you should remind people of what the current warranty is on the Sanders products.
All of my products come with a lifetime warranty. I'm the only one that offers that. I don't think a customer of mine should have to worry about his speakers or amplifiers. If he has a problem in the future, doesn't have to worry about it. We'll take care of it for free.
And Josh is coming down the line someday, right?
Yes, I'm semi-retired. I've been training Josh for the last several years. Josh is now 28 years old. He will be taking over from me. I've had many businesses want to buy my company. I have refused to sell because I don't trust them to take care of my customers well and continue my belief in building only the very, very best products, selling them at a reasonable price with lifetime warranty to take care of my customers. But Josh is my apprentice. He's pretty much taken over the company now. I'm still here on a daily basis to help him out and answer some of the more technical things and continue his training. But Josh is going to be able to continue my company for at least the next 40 years. So I feel I've got a long way to support my customers for a long time. And it's just my policy. I believe customers deserve respect. My job is to have happy customers who enjoy beautiful music. I think the whole idea is to be able to get music out there that people can enjoy like it's live in their home. And to do that, I've had to build my own equipment because I haven't been able to find other equipment that you can buy that's good enough. Although it's gotten better over the years, it's still not as good as what I make, and I think if you hear it, you'll understand. But I'm really concerned with having happy customers. That's my product, happy customers. And I encourage you to look on the internet and look at the forums and stuff and the comments you hear about us and the way we take care of our customers.
Very good. Well, I agree, and I hope to be one of these days soon.
Okay, somebody was asking about King Sound and Martin Logan speakers. These are all types of electrostats, but what the differences are in primarily, as far as sound is concerned, is in the way they're engineered. For example, Martin Logan does not use loudspeaker management systems. They use cone woofers in a box, in a closed box, which is not a transmission line. We haven't gotten into the discussion of speaker design, but transmission lines, when you put a speaker in a closed box, it has overshoot and ringing. That is to mean it doesn't stop when it's supposed to. It continues to resonate for a while and produces sounds that don't belong there. In other words, it produces a lot of distortion after the original sound was produced. It took me and that does not sound like an electrostatic speaker. Electrostatic speaker, having no mass, stops instantly, and it has no ringing because there's no mass to ring. And well, to be honest, I can't say it has zero mass. It has extremely tiny mass. The diaphragm of my speakers is 1/4 of a thousandth of an inch thick, and for all practical purposes, that's massless. And when we hang that in a room of air, the mass of the air totally swamps the mass of the diaphragm. So from an effective engineering standpoint, the diaphragm has no effect on the sound. It just simply transfers its energy to the air. The air is the mass. Now, the point I'm trying to make here is that the speaker, an electrostatic speaker, is totally air damped, which keeps it from ringing and overshooting. And to use an example, let's say you had a tuning fork or a bell. If you ring that bell in the air, it overshoots and continues to ring for a while. You hear it after you didn't hit it anymore. Take that same bell or tuning fork and put it underwater, and now strike it. You don't hear anything. There's no more ringing and overshoot. Well, the air around an electrostatic speaker acts just like water does around a massive object like a bell. It completely damps the resonance. There isn't any. So if you have a woofer that's overshooting and ringing, and you have an electrostatic panel that doesn't, then the two don't sound the same. And you're going to be listening to that, and people complain all the time about Martin Logan speakers, for example. They don't integrate, and that's because they don't. And of course, they're using passive crossovers. They're not using steep enough crossover slopes. They're not time aligned. None of these things are done, and so they don't sound very good. They still sound better than Conodome speakers, but in fact, if I didn't have my own speakers today, I'd probably own Martin Logan's. But they do have clear faults, and these are them. The other thing is that they use my curved electrostatic panel. After I invented that back in 1969, and I published it, I went to get a patent on it, and with additional research, I realized it had too much distortion because the diaphragm doesn't move the same in the forward direction as it does in the back direction, because it has to stretch to move forward in the curve and collapse as it moves backwards in the curve. In severe cases, you even hear it crackle when it does that. That's this credit card crackling sound that some people complain about when they listen to Martin Logan's loudly. The other thing is that they excite the room acoustics. I invented the curved panel to try to get wide dispersion from panel speakers. I was successful in doing that, but then I realized don't want wide dispersion. I don't want the room screwing up the sound. I want the sound from the speaker coming directly to my ears, and I don't want room acoustics messing it up. And by using a flat panel, I'm able to control the dispersion and eliminate the high frequency room acoustics. So I don't need to use a room correction system to deal with high frequencies. Now, the room correction will deal with high frequency response problems, but there's other factors that dispersion ruins as well. Why dispersion ruins the transient response of the speakers? Because you hear all these short reflections from the walls, and they're actually echoes, but your ears don't hear them as echoes because they're too close. They're not delayed enough to the main sound. So in a typical room, you hear all these room reflections. What your ears actually hear, well, let me step back a moment. Let's say we take a single crisp transient just to demonstrate the point, like a rim shot on a drum. If you have a wide dispersion speaker in your room, the speaker is going to send sound directly to your ears, which you hear is a rim shot. Let's assume it's a perfect speaker, it has no faults. It just is wide dispersion. So you hear this perfect rim shot. But in a wide dispersion speaker in a room, you're going to hear the sound bouncing in thousands of reflections off the room that are going to follow that initial direct sound from the speaker, causing your ear to hear what is, for all intents and purposes, a bunch of popcorn going off. A whole bunch of rim shots very, very close together. And your ear really doesn't see that as echoes. So it smears all those transients together into one elongated, smeared transient sound. And that doesn't sound very realistic. That's why I say the transient response isn't very good. And if you doubt that, just think of the last time you heard headphones. Headphones have no room acoustics. And even if they're not very good, the fact they don't have any room acoustics makes them sound really remarkably crisp and detailed. And it's not because they're great speakers, it's because you don't have any room screwing up the sound. So I don't want wide dispersion because I don't want the room acoustics messing up the sound. The next issue is imaging. When you smear the sound all over the room, all those delayed sounds ruin the phasing. Phasing, by the way, is just another word for timing. You want all the sound to arrive at the same time it did to the microphones in the recording. And you can't do that if you have all these delayed sounds in the room. So my curved electrostatic panel, I quickly came to realize, didn't perform very well. And I'm not going to just blow my own horn and say, oh, it's the best because I invented it, blah, blah, blah. It's not the best. And I've had to fight all my life to convince audiophiles that wide dispersion is the wrong thing if you want good sound. Audiophiles today, most of them don't believe me. But once you hear my speakers, you can't help but believe me. But you need to eliminate the wide sound and the point source type speaker. It does not produce a realistic image. The sound comes from the speakers. Instead of forming a three-dimensional holographic image in the room between the speakers, and those of you, it's hard to describe, but those of you who've heard my speakers immediately know what I'm talking about. And that's better sound because you're hearing the direct sound from the speakers only. There are reflections from my speakers in the room, but they're delayed because of the directional nature of the speaker. And they're delayed long enough in a typical room so that there's at least a 10 millisecond delay between the direct sound and the first arrival of the first reflection. Your ear then is able to distinguish between the two, and it produces what's called precedence effect. It hears only the original sound from the speaker. It ignores the reflections in the room. It's an amazing psychological, psychoacoustic phenomenon, but this precedent effect is key to the reason that my speakers sound so different and so much better from an imaging standpoint than what you get with conventional wide dispersion point speakers. King Sound, King Sound makes a bunch of speakers. Most of them are so-called full range speaker. Let me say right off the bat, there is no such thing as a full range electrostatic speaker because the laws of physics dictate that it is simply impossible to get deep, powerful bass from a dipole radiator. This is especially true of electrostats because they're not very powerful speakers. So to play them loudly is not practical in the bass. I'm not going to get into much more detail other than just say that's a fact. And so anybody that's selling a full range speaker is lying to you. There is no full range electrostatic or any other dipole speaker, including magnepans. Magnepans have a lot more power. They can, because they're magnetic, they can drive the diaphragm much harder than an electrostatic can. But you still can't get deep, powerful bass out of a magnepan speaker. And so what most audiophiles do is, they buy this full range electrostatic speaker. And then they say, well, it's got lousy bass, so I need to get a subwoofer with it. Well, now they don't have a full range electrostatic speaker anymore, do they? They have a hybrid speaker, which is what I make, except it's a terrible hybrid speaker because subwoofers make terrible woofers. Subwoofers are designed to reproduce very deep bass frequencies that you hear in video special effects like explosions, train wrecks, earthquakes, things that normal woofers can't do very well, but music doesn't contain those things. But for music reproductions, subwoofers are way, way, way too heavy, way too slow, have terrible transient response, terrible frequency response, and they have just awful overshoot and ringing. They're awful speakers to mate. So you buy this full range giant electrostatic speaker that's supposed to be full range. It doesn't do what it's supposed to do because it can't play the bass. And then you make your own hybrid out of it instead of buying a customized hybrid like I make with a transmission line woofer system that's able to actually not have any overshoot and ringing. And I can get into that technical detail, we just don't have time. But take my word for it, I spent 17 years trying to solve this problem of integration between dynamic woofers and electrostatic speakers, and I have succeeded. It has taken a lot of work, and it takes a very complicated, difficult woofer system to do that. So King Sound does make, I think, one hybrid, but again, they just use a cone in a box with a passive crossover, which doesn't integrate. Also, they're made in China. They're not very reliable. In fact, the American distributor, the last I heard, no longer sells them. So I don't know if they're even available in this country now. But if you want to get a Chinese speaker and you're willing to put up with the unreliability, by the way, my electrostatic speakers come with a lifetime warranty. Try getting that from Martin Logan or anybody. They just don't happen because electrostatic speakers tend to not be very reliable because of the high voltages involved. But mine are reliable. I have them in use for over 20 years in lots of people's homes, and they're still working like the day they got them. I've never had any failures. It took me 40 years to come up with a solution for that, and it's very expensive to have to build electrostatic panels the way I do, but they are reliable. Now, there was another question about Class D amplifiers. I'd like to get to that very quickly because it's an important point. Class D are switch mode amplifiers, or amplifiers that are nonlinear. They do not turn their output transistors higher or lower in an analog way to produce their signal. They either turn their transistors fully on or fully off. And they do this at very high frequencies in order to sort of average the power in the signal to achieve an analog waveform. They're really not very good at it. And and that means they have lots of distortion and lots of noise. And to deal with this, they have to use what's called a Zobel network on the output to sort of filter all that noise and crap out of there and try to make them smooth. They also use tons of negative feedback because they have such high distortion. They got to use massive amounts of negative feedback to suppress the distortion levels. Now, the big okay, you say, what's the advantage of using digital or switch mode amplifiers? There's only one advantage, and that is they can be more efficient than linear amplifiers like Class A or Class AB amps because they're not turning their transistors on just a little bit. Because anytime basically a transistor is nothing more than a variable resistor. You apply the power supply voltage to one side of that resistor, and then you turn the resistor on more or less, or you turn the transistor on more or less, which changes its resistance. It either has a lower resistance and flows more current to the speaker, which makes it play louder, or it has less resistance, higher resistance, which resists the flow of electrons and makes it play quieter. So by turning the resistor on and off more or less at different frequencies and at different amounts, you can get music. It's really simple. So basically, this transistor is turning on and off partially, not fully on or fully off in a linear amp. Now, anytime you put a voltage across a resistor that you're losing power through in order to have a varying voltage at the output or a varying amount of current at the output, you're going to dissipate heat in that resistor. And so linear amplifiers get their transistors hot. That's why they need heat sinks, and that's why they run hot when you play them hard. The harder you run them, the more heat they have to dissipate, so they're going to get hotter. And as an aside, there's also a bias current used to eliminate crossover distortion. I won't get into the technical details due to time here. But anyway, there is a bias current, and subheat is produced in that as well because the transistors are kept turned on a little bit by the bias current. Now, when you have a Class D amplifier, you try not to have the transistors turned on partially. You want them fully turned on, which in theory they would have no resistance and flow current freely with no heat, or fully turned off when they have total resistance and won't pass any current and have no heat. So when you use a switch mode amplifier, you're able to eliminate most of the heat in the amplifier. You don't get all of it gone though, because the transistor won't switch between off and on instantaneously, although it'll do it awfully fast, several megahertz. But nevertheless, there is a very small amount of time when the transistor is turning on and turning off when it is partially conducting and therefore producing heat. But there's no question that a well-designed Class D amplifier will have cooler operation than a well-designed Class AB amplifier. And I'm not even going to mention Class A amplifiers because they get so damn hot, they're useless. You can't get enough power out of one to use it. And they don't sound any better than a Class B amplifier anyway, a Class AB amplifier anyway. Again, that's another whole topic we can get into. But my point is the Class D amp has only one advantage, and that is it's more efficient, it runs cooler. And if you're in a professional application where you need hundreds of thousands of watts of power to run your stadium PA system, that's what you're going to want to use is Class D amplifiers, and that's where they're sold mainly in the pro market. The problem for home use is that there's a lot going on inside one of these amplifiers. They're complicated and there's lots of parts, and they're switching at megahertz speeds, and they tend to be unreliable for that reason. Secondly, they produce a lot of radio frequency noise. It's very hard to get the radio frequency noise out of a high voltage, high switching device. And engineers have gotten pretty good at it, but you don't have this problem of high voltage switching and electrical noise in a linear amplifier. Thirdly, and the biggest problem, and the thing I'm going to say is that the thing that makes Class D amplifiers or switch mode amplifiers not high fidelity amplifiers is that they do not have linear frequency response. It is impossible to make a Class D amplifier that will drive all loads linearly in the high frequencies. And that's because their Zobel network has to be designed in such a way that it works with the load that it's driving in order to produce linear frequency response. This means that you can only get linear frequency response out of a switch mode amplifier if you know what speaker it's driving and you specifically design its Zobel network for that load. And that works just fine if you have something like a powered subwoofer. That you know what the load is, you need lots of power, you need a highly efficient cool running amplifier. So you get a switch mode amp and stick it in the box with the subwoofer, and you get linear frequency response out of it, no problem. But the idea of buying just off the shelf a so-called wideband switch mode amplifier to drive any full range speaker does not exist. They will all have serious errors in the high frequency response. Now, this doesn't mean they necessarily sound bad, because sound to some people is like wine tasting. You may like high frequencies that are maybe subtly suppressed and muted by the amplifier. You may find that gives it a richer sound and a smoother sound and whatever you think it sounds like. Or in some speakers, they boost the highs and they cause it to sound brighter. Well, that also makes the speaker sound more detailed and maybe more clear to some people. It's not linear, but they like the sound better. I mean, that's why we equalize things. Remember the old receivers, you could turn the treble up or down, or the bass turned up or down. Well, that's equalization. It's non-linear, but you like it. If you want the bass cranked up, you crank it up and you like it. That's no fault of the equipment, and it's no disparagement on the listener. If you want more bass, or the room requires more bass, turn it up. It's not a linear amplifier then, but it sounds fine to your ears under your particular situation. And that's okay. So there are people who buy and like the sound they get out of their switch mode amplifier. But if they were objective about it and actually measured it, they would see it's not linear. And the whole idea of, quote, high fidelity sound, which is what this used to all be about before we start calling it high-end audio, high fidelity sound is all about music in a realistic manner. And to do that, you had to have a linear amplifier. So I do not approve of switch mode amplifiers except for driving woofers. For example, in my speakers, they're bi-amplified because I don't compromise. You can't use a single amplifier to drive multiple drivers well. So, and you can't use a loudspeaker management system with a single amplifier. You've got to use multiple amplifiers. And so I give you an amplifier with my speakers, so you only need one amplifier like you'd buy with any other speaker. It wasn't multi-amplified, but or bi-amplified. But you still need another amplifier. In the case of driving the woofer, a switch mode amplifier, they're cheap, they're powerful, and you don't care about high frequency response in the woofer because it's not reproducing high frequencies. So if you want to use a Class D amplifier on my speakers on the woofers, that's fine. But don't use them on electrostatic panels. I'll tell you, the frequency response is horrible. And I wouldn't use them on wide bandwidth speakers either because they're just not linear. But they are cheap, they have a lot of power, and that's one of the best things about most of the switch mode amps. It's easy to get a lot of power out of it when you're not having transistors partially turned on. So most switch mode amps have a lot of power, especially because they're all designed for professional applications. And the manufacturers for high-end audio who use switch mode amps, they basically swipe one of the modules from the professional guys and then sell it as a high-end amp. Other questions?
Well, someone's asking about electrostatic headphones. Are you knowledgeable in that category, Roger?
Sure. I didn't catch the whole question. Could you put it back up there?
I think it's up there. It says I have the COS ESP 950s, and they're great for all the things you've mentioned. So
Yes, go ahead.
I think he's just confirming that now he knows why he likes what he has.
Yes, the COS ESP. I had a pair of COS ESP 9s I used to use for on-location mastering. They're like audio magnifying glasses. They're incredibly detailed, and they're completely enclosed to eliminate all outside sounds. Now, most of the headphones, electrostatic headphones today, are open, so they're like miniature speakers hanging on your ears, but they're open to the outside, so you can't use them for monitoring. And of course, people do hear them around you, but nevertheless, they can be very good. Unfortunately, a lot of them I've heard, they are not very linear. I don't know why they haven't solved the linearity problem, but they're very colored. And from that standpoint, I think it's a problem. But in general, headphones listening is not very satisfactory because headphones do not give you a realistic image. You get all this wonderful detail and incredible positioning of the instruments, but it's all in the middle of your head. It's not out in front of you on stage like speakers present, which is really too bad because headphones really do have great advantages in that regard. The other problem with headphones is that they can't produce good bass. They can produce loud bass in your ears, but when you really have good bass, you don't hear it as much as you feel it.
Right.
And so when you get down, in the low 30 hertz range, it's really sound that you feel, not sound that you hear. So although you can take good headphones like my COS ESP 9s, I used to record pipe organs with them. And when we get into the deep bass on those pipe organs, I could literally feel my eardrums flapping, but it didn't sound like I was listening to a pipe organ bass. You had to take your headphones off and actually listen to that air pumping against your chest. Now that's it. That's the bass. So headphones have some real limitations. But as far as if you want clarity and detail and you need to be in a quiet environment, there is nothing better than COS ESP 9.
Interesting.
Jeff, can you hear me?
Yes, Keith, go ahead.
Well, can I ask some questions at some point?
Why don't you ask him now? Roger, can you hear Keith?
Yes, I can.
Okay.
Yeah. Now, you might not completely approve of this, but I have an electrostatic speaker, some electrostatic speakers, but they have passive crossovers. I have a pair of Jansen Valentina P8s.
Okay.
And I've been pretty happy with them. I've only had them for about 2 months. But to that end, what you said something that really piqued my curiosity about amplifier power. I'm using a power amplifier that I bought 25 years ago, and I was wondering if it would behoove me to upgrade my amplifier, and whether your amplifiers, should I even consider them for a speaker like mine that has a passive crossover?
Well, certainly you can use my amplifiers on any speaker, including passive crossovers. But that's not the issue. The issue is, what can you do to make your speaker sound better? Now, Jansen made a whole lot of speakers, and I'm not familiar with the exact one you have, but I assume it uses multiples of their 4-inch squared tweeter, right?
No. I have a pair of bookshelf speakers that are like that I bought in 1975.
Okay,
but their current product has it's a newer panel. I don't know the details on it, but I know what you're talking about, and it's not that.
Oh, you're talking about the new Jansen tweeter speakers?
Yes.
The current ones?
Yes.
Okay, that's Jansen's son, and he uses passive crossovers and multiple drivers. Okay, first of all, sure, my amplifier is specifically designed to drive electrostatic speakers, and it would be ideal. Go ahead.
What makes them specifically, what are the characteristics that make them ideal for electrostatic speakers?
To do that, you have to understand the problems of electrostatic speakers that they present to amplifiers. And I have a white paper on my website. Okay. I don't know if you've been to my website, but I suggest you go there after this meeting and go to click the tab on technical white papers. And on there, I have a bunch of white papers on technical stuff like this that would probably be better for you to read than for me to take the time now to say it. But
Okay.
I will just anyway, go on there, and there's one about ESL amplifiers. It explains in technical detail, but in layman's terms, exactly what's going on with regard to safe operating area of transistors, highly reactive loads, the phase of the current leads the phase by 90 degrees electrostatic speakers. The power is not dissipated as heat, it's reflected back to the amplifier, which tends to blow up transistors, tends to trigger protective circuitry. I mean, it's just a whole bunch of problems with this. And I'll just summarize by saying, we designed my amplifier, I had to, because I was making electrostatic speakers and I couldn't get amplifiers to drive them well. So I had to design an amplifier that would. And to do that, I had to make an amplifier the hard way. I could not cheat by using protective circuitry to save the transistors. And protective circuitry really triggers dramatically on conventional electrostatic speakers. And the protective circuitry chops the power on and off to the output transistors to save them. And it does so very quickly, so you don't hear it happening, but it causes harshness, it causes a tremendous loss of output, it causes high distortion levels, it causes listening fatigue, it causes this, after you listen to it for a while, there's an edge to the sound that's irritating as hell. And this isn't caused by transistors. Again, another myth in the audiophile world is that transistors sound differently than tubes. Transistors do not sound any different than tubes. What sounds different is the protective circuitry in transistors that screws up the sound. And the so-called transistor sound is not caused by transistors. It's caused by the protective circuitry used in almost all transistor amplifiers. Now, my amplifier solved this problem by not using any protective circuitry. I couldn't use any and get them to perform well with electrostatic speakers. But now I've got this problem of blowing up output transistors. To solve that problem, I had to use massive output transistors and a lot of them. I used 20 output transistors, each capable of 15 amps and 400 volts in order to reduce the load on any transistor. So even though we're trying to drive it outside its safe operating area with an electrostat, it won't blow up. And I proved that by giving it a lifetime warranty. Now, the problem with that is it cost me a hell of a lot of money in output transistors and output stages, and big, massive output stages that are very expensive. So my amplifiers cost me a lot of money, but that's what it takes to drive electrostatic speakers. And because they will drive electrostatic speakers, and they'll do it at high power levels, at 1,000 watts, they'll also drive conventional speakers with great ease. So my amps, although I've designed them for electrostats, they'll drive any speaker, and they'll do it with great power and with complete reliability. So that's why they're basically different.
I'm not going to ask you right now about how expensive they are, but I could consider it if I could be absolutely certain that I would notice an improvement over what I have now, which brings me to my question. And you'll have to excuse me, I had never heard of your company until tonight.
Okay.
So
You haven't looked at our website. I have his stuff on our website under the university.
And you don't need to apologize, and you don't need to apologize for asking questions. There's no such thing as a stupid question, only stupid answers. And none of us know everything. So if you have a question, sure, ask it, no problem. Anyway,
do you sell directly or through dealers?
Yes, I sell factory direct. That's why I can sell so inexpensively. My amplifiers only cost $5,500, and a stereo amp will do 1,000 watts per channel, and it comes with a lifetime warranty. And everything I sell, I insist on customers being satisfied. It comes with a 30-day in-home trial. If you don't think it's the best amplifier you've ever used, I not only allow you to return it and refund your money without any penalties like restocking fees, I even pay free return shipping, and I demand that you return it. I don't want anybody out there with my stuff that doesn't think it's the best out there. Now, I'll also add, we sell thousands of amplifiers. And in my whole life of selling these, which has now been 14 years, I guess, this particular amplifier, I've only had 2 of them returned. And I've had them returned for reasons other than they didn't like the sound. One guy's wife bitched about him spending the money. And the other guy died, and his family didn't want it anymore. So they sent it back. But I don't have anybody that doesn't like my amplifiers. And I guarantee you'll be satisfied. Try
So
one. If you don't like
you
it,
don't-
send it back.
It's double your money back, Keith. Come on.
Well, no, this sounds the price you mentioned sounds it's a sum I could make some sacrifices with and deal with, but I just want to make a comment now that I've had electrostatic speakers before,
Yeah,
and they usually catch my ear,
right.
and with the ones I have now, I realize they may not be as nice as yours, but I have experienced two phenomena with them that I've never heard on any other speaker. One is they sound really good at low volumes.
Right, that's what I was talking about. You get that
Yeah.
electrostatic detail at low levels you don't get in magnetic speakers.
And another situation, and I've told Jeff about this in the past, I think he can vouch for me, is I've listened to some music that now my speakers are 13 feet away from where I sit, but there have been times when I could almost swear I could reach up and I could touch the instrument that I'm hearing. I mean, it sounds as though the images are in front of the speakers sometimes. And is that what you meant by holographic imaging?
Not exactly. Holographic imaging has to do with 3 dimensions. A holograph is a 3-dimensional image. It's
Yeah.
unusual. Most images are, like they're 2-dimensional, like a picture on a wall. A holographic image looks like there's actually depth to the picture. And with speakers, you have this problem. Most speakers are 2-dimensional. They don't give you good enough phasing and time cues to really produce a 3-dimensional depth of image. And it's hard to describe. You have to hear it. You are hearing some of that, though, with the speakers you have now. That's why you feel that it's out in front of you. You can touch it, that sort of thing. But there is a depth to a good recording. For example, if you listen to symphony orchestra, the violins are closer to you. If you're in a concert hall, you can hear that the violins are closer to you than the brass is. And that's because the sound from the violins arrives at your ears slightly sooner than the brass. And you need to be able to reproduce that in a speaker system in order to get the sense of depth. But most speaker systems don't give you those timing cues because they're so messed up with the room acoustics, with all these delayed sounds, that your brain can't pick out any specific time cues to give you the depth that you hear. And there's no way to describe this orally. You simply have to hear it. The next time you're in the Denver area, come by my place and listen to it. Or order out my speakers, take them home, listen to them for 30 days, send them back. Whatever you want. But I'm just saying, you have to hear it to know what I'm talking about. But while I don't think that the Janssen speakers are the best that could be, they nevertheless are quite good. And they do have a large electrostatic element that gives them a lot of support. And so you're getting a lot of that electrostatic sound and the imaging produced by it. So yeah, you're catching into that, and you're appreciating that it sounds better than Codes and Dopes, because it does. And if you put enough power on it and a better amplifier, you'll hear a difference too.
When I was shopping for them, I selected them over Magnapan 3.7i's and some Martin Logan speaker, I forget what, and I selected these. And the reason I asked you if you sold direct is because I have found dealing with companies that sell direct, it's easier to audition things at home than it is from a high fidelity dealer, unfortunately.
Yeah, I've been trying to get away from dealers. I have dealers that sell my product and dealers that beg me for my product, but I don't like selling through dealers. To begin with, when you buy from a dealer, you're going to pay 50% of the price as product to him. That's profit to him, which means that if I sold through dealers, I'd have to double my prices just to maintain my profit margins. So you're paying a huge price to buy through a dealer. Secondly, they're not very loyal. They don't really tell you the truth about things. When you have a problem, they tend to complain about it. They don't want to really give you very good service. There's an occasional exception, but most dealers, they just want you to walk in and buy something and walk out. And they don't really understand the details, the technical details of their stuff they sell, as well as the manufacturer does. And also, the dealers have almost become extinct. If you look at 30 years ago, we had, compared to the number of dealers that were out there selling high-end audio 30 years ago, we're down to about 5% of those. All the rest have gone out of business. And I want to sell worldwide. In fact, I sell more of my equipment internationally than I do domestically. And I could not sell, for example, I got customers in places like Pakistan and Laos and places where there are no dealers. So I sell factory direct. and we can take care of customers much better than dealers can, and we can keep our prices low. And remember, my purpose in life is to get people to enjoy beautiful music in their homes, and to do that, they got to have the equipment to do it, and so I sell it direct, so I can do that.
Now, I
And
don't
keep the
have any
price
kind
down.
of, I don't have a speaker management system, but what I have endeavored to do is I recently acquired a real-time spectrum analyzer application for my computer, and I have a measurement microphone, and I intend to use that to determine whether the level coming out of my electrostatic speaker is set correctly relative for the woofers that are in the speaker. So, do you see
for
any
you.
big pit? Do you see
Good
any
for
big
you.
pit?
Everybody should have a room correction system, and a good room correction system will have either a real-time analyzer in it, or a fast Fourier transform, an FFT analyzer. The one that I use has both, and also an independent real-time analyzer that you can use if you prefer that. But the FFT analyzer is the better solution, because it measures all frequencies, not just bands of frequencies. Anyway, anything's better than nothing, and what you're proposing is a good idea. I approve 100%.
Okay, well, thank you. Well, I'll take a look at your amplifier.
How many watts is your amp now, Keith? I forget.
The amplifier I have now is a Mark Levinson amplifier I bought probably, well, it was 25 years ago. It's a Mark Levinson 333, and it's 300 watts into 8 ohms, and it goes up to 1200 watts into 2 ohms.
Okay, I would caution you, Levinson amplifiers are not able to drive electrostats very well, and they break a lot. And
Well,
I've even had talk to Martin Logan about it, because several of their amplifiers have been blown up on my speakers, and Martin Logan, the company, actually admitted that their amplifier is not really suitable for driving electrostats. And
Well,
yours may work okay, but I just want to warn you, you may find it fails, and it may not fail right away.
Well, that's one reason I'm here, is to find out my pitfalls and the alternatives. I did have quite a major repair on them several years ago, but I didn't have electrostatics then. Back then I had a pair of Carver Amazing loudspeakers.
Yep.
And I don't know if you're familiar with those, but they're
got ribbons.
Yes.
You're talking about the ribbon column with the woofer underneath?
Yes,
Yeah.
they're notoriously inefficient.
Yeah, but well, basically it comes down to, I hate to just badmouth products, but the Mark Levinson amplifiers are not very rugged. They just can't handle it. And you're perfect proof.
All right. Does anyone else have a question? Because we've run well over Roger's time. And Roger, I appreciate you not complaining about hanging around and answering everybody's questions.
No, I'm happy to help here. You know, I'm past the audiophile stuff where I have to argue with people. I just tell it like it is. And,
yeah, I know you do.
Let it go. And you could have a couple months if people have more questions. I'll be happy to do it again. No problem.
Yeah. Okay. Well, that's great.
And the other thing is anybody can just call us anytime and talk to us about things. That's what we're here for.
It's a 2-day drive. They can come up and listen right in your living room. If they want to.
They could do that too.
There you go. Okay. Well, anybody else with any questions, or are we going to let Roger go?
Somebody asked what room correction system to use. Actually, there's quite a few good ones out there, except the only thing I would say is I probably would not use audiophile ones because they're just too expensive. Get professional ones. The loudspeaker management system I use in my system is, there's a smaller version, a simpler version of it. I use the DBX Venue 360. The retail price of that's around $800-ish, but they have their PA2 version, which has some, not all the features of the Venue 360, but that wouldn't matter for most. It would meet almost any other needs out there, and I believe they sell that for around $400, and it'll do a whole loudspeaker management stuff I've talked about. But you can use it just as a room correction system for $400, and it's a really good one. It uses a FFT analyzer instead of a real-time analyzer, so it's a much better system, and it's all automated, does it really quickly, and anyway, it's just a great system. And for $400, how can you complain? What's not to like?
Yeah. Okay.
But there are plenty of others out there too. I mean, all the pros use them, but I think the DBX has the most advanced ones, and the prices are a little higher. I mean, $800 for a professional loudspeaker management system is, in the professional market, considered quite expensive. I mean, you could buy crossovers, electronic crossovers in the professional market for $50 that work just fine, that you would pay $5,000 to an audiophile company for. So, you know, the pro stuff is a real good bargain and it works great. But they don't make stuff for eye candy. So they're not going to have a really fancy chassis. They're not going to look real pretty and that sort of thing. But if you want to have it work well, I see the DBX system, to repeat, is the PA2. PA is in Papa Alpha 2. And if you ask for that, or you can go online anywhere and buy them.
Okay. Well, that's great information, Roger. I knew it would be fascinating, and I didn't have to get too involved with the questions because you have a lot to say, and I just ask a question and sit back and listen.
We could talk for hours.
Yes, we could.
But you know, mostly what I'm going to give you is engineering stuff. I'm not going to give you audiophile talk.
Yeah, well, that's what people need to hear because we're all getting the wrong stuff crammed in our heads every time we pick up a magazine.
That's for sure.
Yeah. Well, and how can you get out of your house now? Is the snow gone?
Yeah, the snow is melted off about last week. The last of it's gone, so we can get out now, and the weather's turned nice. It was like 62 degrees here today, so it was very nice.
Wow, that sounds good. Okay, well, I'm gonna leave my part on. Are you recording this, Paul, or am I?
I'm recorded it. I just want to say, Roger, thank you so much for your time. I've actually heard your system twice, and it is quite lifelike. Wouldn't work for my little room, but in the right room, it's astonishing, and it's just realism at its best. So,
actually, thank you for the compliments. Let me point out, though, it does work extremely well in small rooms. In fact, we have several recording studios that buy them because they take the place of headphones. They really like them in small rooms because they can have this controlled dispersion. They don't get all the room acoustics going. And of course, the room correction system works well. So you've probably heard them at some shows. And of course, the hotel rooms are very small. So small rooms did not rule out the use of my speakers. They work great in small rooms. And you can listen quite up close to them without any weird effects. So I think you'd be surprised. It would work in your small room. But I understand it's not for everybody, and that's fine. But if you really want super sound in your small rooms, they'll do it better than anybody else's speakers will.
I forgot about the low level advantage too. That's a nice thing because I do listen at low levels a lot.
Yep. Okay, great.
Roger, this is Pete. I heard your system at the RMAF, and I think twice now, and it was in a relatively small room, and I really, really loved it. It was actually amazing, and including not only the clarity and the detail, but that bass, like it blew me away. So,
not what you're expecting from an electrostatic.
I would love to own one of Roger's systems, that's for sure.
Well, there's somebody discounting one online. You can buy a secondhand one for $11,000. I saw that. That's about one every 2 years that comes along.
What is the going rate, if I may ask, for a brand new system from you, Roger?
Our full 10E system sells for $17,000. Keep in mind that includes not only the loudspeaker management system, but the Magtech amplifier to go with it, which alone is $5,500. So you get the whole system for $17,000. Now we also have, I really do try to help people get good sound, and I can help if money's a major issue. We can also work around that to some degree. For example, if you already have suitable amplifiers, I can take the amplifier out of the system and sell you the speakers alone for $12,000. I can also put you onto other amplifiers that are cheaper. For example, you could buy a used use ADCOM 555s, turn out to be particularly good amplifiers for driving electrostats and woofers as well. And you can pick them up for around, oh, 500 bucks or so used. ADCOM 5, I forget the first letters, but anyway, it's the 555. It's rated about 200 watts per channel into 8 ohms, which into 4 ohms, which all speakers are pretty much nowadays, means it'll do about 400 watts per channel, which is getting right up there to 500 watt limit minimum. So it's right up there. But the point is, you can pick them up for a few $100s used online. They'll do a good job, and they can save you quite a bit of money on my speakers if you want to use those instead. In fact, there's some professional amps that you can use. The most amazing one out there for the money, if you need a high power amplifier and you don't want to use a switch mode amplifier, you want to use a linear amp, Behringer, probably heard of Behringer, it's a professional company, makes very low cost professional equipment. But the Behringer Europower 4000, the EP4000, is a Class AB amplifier with a Class H power supply, so it runs very cool, but it'll do about 1,000 watts per channel into 4 ohms, and it only costs about $500, brand new.
500.
Yeah.
Wow.
But of course, like all, it does have some disadvantages. First of all, it's professional stuff, so it's cheap chassis. But you know, who cares? It works. It's got good guts in it. It makes sound. And like all professional amps, it has a cooling fan in it, and the cooling fan makes some noise. Now, in a concert hall, you don't care, but in your home, the fan running may annoy you. There's ways around that, though. I've had customers. I helped them. We took the fan out of it, and it's got a horizontal heat sink inside of it that the fan blows through. Well, that won't cool if without the fan, unless you turn the amplifier on its nose, on its face. Now you got a vertical heat sink, and the heat will flow through there by convection, and you can stop the fan, and it runs cool enough that you can run it without the fan. But you know, it looks stupid standing on its face, but you can kick it behind the couch if you want. You don't have to look at it. And because it runs very cool, because it's Class H, it runs as cool as a switch mode amp, because there's no, well, anyway, it's Class H operation. That's a whole other thing to get into. But the point is, there are ways of getting the cost down. Another thing is, we occasionally have blemished equipment, and we give a $500 discount on any blemished equipment that we've got. So, you know, it's conceivable you could pick up a new speaker system that's blemished from us for, you know, $11,500, something like that. And maybe you've got an amp right now that's suitable to drive the woofer. You may need another amp to drive the panels, and you might get an ADCOM 555 for that. So, you know, you can manage. I mean, we can help you, give you guidance, because yeah, we like to sell our own stuff, but we're more concerned with helping the individual customer. And if I can set you on something that makes it possible for you to get into our electrostatic equipment, I'll do that, even though it's costing me a sale. The good news is we're an extremely successful company. You know, I think we're going to see an awful lot with this epidemic or pandemic that's going around. We're going to see a lot of high-end audio companies going out of business because they just don't have the money. But we have money in the bank. We have plenty of inventory in stock. We keep everything in stock. And I've been surprised. Our business has actually picked up since the epidemic started. I mean, I sold 4 loudspeakers in the last 2 weeks. And, you know, that's a good-sized chunk of money. And we're actually making money right now, even though I've got plenty of money in the bank. But nevertheless, we're going to be here when others aren't. And I can afford to lose a sale to help you get an amplifier that you can afford. And I'm willing to do that. I'm not here just to try to make a buck.
Well, thank you. Nice. Yeah, that attitude is wonderful. I love that.
Yeah.